we're talking about inverse and joint variation. We have already done direct variation. It's been a while. I think that was actually first semester. Your direct variation equation was that. Does it look familiar at least? The words maybe at least sound familiar. You should recognize at least something about that. Okay? With our constant is which letter?
K.
It's your K. Alright, so what they did is they told you that y varied directly with x, and then they would give you some information and you would solve things out, and you would get just a standard equation. Or they'd give you an x and you'd solve for a y, or something like that. Okay, today we are going to start with inverse variation. Okay. If they tell you that y varies inversely with x, it's going to be y equals k divided by x. Okay. Your k cannot equal 0. Okay, that's kind of your rule with your constant. Your k cannot be 0. Okay. Otherwise, it's kind of exactly the same as direct. They're going to give you some information, and you're going to solve it. So, we're going to take a look here at a few different equations. They're going to ask us, are they direct, inverse, or neither, as far as variation goes. Okay, so remember, inverse is something equals your constant divided by another number. Direct would be multiplying. Now, is it possible that maybe you have x equals k over y? Yeah. Okay, that just means x varies inversely with y. Okay, so that is a possibility. Okay. Where's my example at? There we go. I have x, y equals 4.8. We have to decide, is that inverse, direct, or neither? I've heard all three answers. Okay, I'm going to tell you that Brody's is right with inverse. Why? Yeah. Do either of my equations have both variables x and y together? No. So if I divided this by x, I would have y equals 4.8 over x. That's exactly what inverse variation is, right? I have some variable equals my constant divided by another variable. Okay, so this would be inverse. Okay, second one, I have x equals y divided by 1.5. Personally, first glance, I think neither. Okay, but it's not neither. Oh, kind of, yeah. I wouldn't cross multiply because there's not really a fraction over here. But what I would do is I'd say, okay, right now I'm dividing by 1.5. So to get rid of that, I need to multiply by 1.5. So I actually have 1.5x equals y, which is direct. So is it possible that at first glance it does not look like it has any variation, but you can simplify it or rearrange it, and it does? Okay, so just be aware of that. Use your algebra skills to rearrange things. Don't make anything up, okay, but use the skills that you know to rearrange things and try to get it into either inverse or direct variation. They give you an example there on part B. They give you y equals x plus 2. anywhere in any of our variation, is there any addition or subtraction signs? No. That should be a dead giveaway that that's neither. Okay, if you see addition or subtraction, that's probably not okay. Okay, so this would be neither. Okay. Now, an example of where they're going to use this, yeah, they're going to ask you to decipher which one's which. Okay, is it direct? Is it inverse? Is it joint? Okay, but the main thing that they're going to give you is an example like example 2. They're going to tell you that x and y vary inversely. Y equals 6. X equals 1.5. Okay. Part A wants you to write an equation that relates x and y. So basically, you're trying to come up with an equation that you could plug any x and y into. Okay, not just these ones. It told us it varies how? Inversely. Okay, so I know that inverse variation is y equals k divided by x, right? I already know some of these variables, so Jack, what would you do here? If you already know some of them. Plug them in. So instead of y, I have 6 equals k over 1.5. And to be able to write a standard equation, remember all of our equations have an x and a y in them at the end, right? So I need to know what k equals. So I multiply by 1.5. What's 1.5 times 6? 9. So I get that k equals 9, right? Okay, that's good, but is this my equation relating x and y? No, what's my equation relating x and y going to look like, Jedediah? It's this, but now instead I know what? I know k, so it's going to be y. Good. Okay. So basically what they're asking is they want a standard equation where if they gave you an x, you could figure out what y was, or vice versa. Okay. So would these satisfy the equation if I plug these in? Yes, they would. But they want an equation where you can figure out any others that satisfy as well. Okay, so that, I guess that was actually... Oh, and then part B says find y when x equals 4/3. Okay, so they give me my equation, y equals 9 over x. How am I going to find y? Instead of x, I'm going to plug in 4/3. When I divide by a fraction, I flip it and multiply, so I have 9 over 1 times what? 3/4. 9 times 3 over. So y equals 27/4. Okay. I know the wording on a lot of that's funny. Okay, so just understand when they want you to write an equation relating x and y, you're going to have x and y as variables. Okay, you're going to have to solve for k and plug it back in to get your equation. Okay, it's the exact same thing we did with direct variation, except now it's inverse. Otherwise, it's completely identical. Okay. The other one we need to talk about is joint variation. Which is a little bit different because your x and your y actually end up on the same side most of the time. Z equals k times x times y. Okay, this is said that z varies jointly with x and y. So it's almost, I've had people in the past say it's almost like a double direct variation. Kind of. Okay, z equals kx and z equals ky. Okay, not exactly, but you can kind of think of it that way if you would like to. It's all multiplication here. Okay, there's no division. Okay, so if they were to tell me that z equaled 4, x equaled 6, and y equaled 3, and they want an equation relating z, x, and y, what would I do with those three things to solve for what? K. And then once I know k, I would do what? Leave x, y, and z as my variables. So I would have 4 equals k times 6 times 3, which is 18. So I actually have 4 divided by 18, which is 2/9, which is what k equals, right? Okay, so now my final equation, Derek, would look like what? And then they could give you any two variables and you could find the third. Okay. Questions on that? Okay, let's do a few examples here that have some confusing terminology here. They want us to write an equation, okay, for the following statements. The first one says y varies directly with x and inversely with z squared. Okay, that's a little different because we got two things going on there. Okay, so let's do the first part. How do I show that y varies directly with x? Y equals kx. Okay, that shows itself that y varies directly with x, right? And it also varies jointly with z squared. So you would divide the whole thing by z squared. Okay, so if you hear the word inversely, whatever that next thing is goes on the bottom. Okay. Let's do another one here. I got 4 more of these. Y varies inversely with x cubed. Y equals k over x cubed. Y varies directly with x squared and inversely with z. So directly with x squared, inversely with z. 2 more. Z varies jointly with x squared and y. Varies jointly with x squared and y. And the last one, z varies directly with y and inversely, wrong problem. Y varies inversely with x and z. Good. questions on any of those? Hey, just follow your words carefully. Inverse means it goes on the bottom. Okay, direct and joint mean you're multiplying. Any questions? Okay, let me know if you do come across some questions in your problems. There's a few examples that we didn't really talk about. There's some data ones with some charts. Okay, you have to set those up and try to figure out, are those inverse, joint, or direct variation? Again, tomorrow we're going to jump all the way to 9.4. I know there's going to be a lot of people being gone this week. Okay, understand that if it's a school activity, you are responsible for those things.